Hello and welcome back to Calculus. First, I'd like to thank all the nice people that support this channel by liking and subscribing. Today will be the final part on pure theoretical calculus. Starting from the next video, I can finally show you how to apply everything we have learned so far to find areas and volumes, solve differential equations, which represent real-life aspects more accurately than traditional functions, and much more. However, before we get there, let's finish the last part of theoretical calculus, specifically cyclic integration by parts. At this point, you already know what integration by parts is. You also know the fact that sometimes you might need to apply it a few times to solve an integral, or perhaps mix it with integration by substitution. In some integrals, especially those involving products of exponential, trigonometric, or polynomial functions, using integration by parts once does not fully solve the problem. It just transforms it into another integral. But when we apply the method multiple times, we find ourselves looping back to the original integral. And this is what's known as cyclic integration by parts. In these cases, the idea would be to recognize that the integral recurs that forms a cycle. Once that happens, we can treat that original integral that repeats as an unknown and solve it algebraically. It's basically a clever trick that turns a seemingly endless loop into a solvable equation. So now, let me show you how it works with one classic example. Let's say we're tasked with solving the integral e to the power of x times sine x. Please note in the front, I wrote I equals. Now I basically represents this entire integral, and I will show you afterwards why exactly I wrote this. Now at this point, you're already fluent with integration by parts, and so let's just say that our u is going to be e to the power of x, and our v prime will be sine of x. So that means our v is going to be negative cosine of x, and our u prime will not change, and it stays as e to the power of x. Now that means that next up we're going to have ex times cosine x with a negative in front because of our v here, and minus the integral of u prime e to the power of x times negative cosine x. Now please note, since cosine x carries a negative sign and integration by parts also carries a negative sign, I can simply change this to a plus. Okay, now for the other integral that we got here, you might notice that we need to use integration by parts once again. Here, I'd like you to pay attention to one thing. Please note that if you choose your u as the exponential function in our case, please stick with it for the second time when you do integration by parts and still set u as e to the power of x. Because if you set u as ex for the first time, but then set u as cosine of x for the second time, your result will be incorrect. So whichever one you choose, please stick with it. So that means we chose our trigonometric function as the v prime in the first integral. So when the second time when we do it, we still choose v prime as the trig function cosine of x. This means that v is going to be equal to sine of x, and in this case u prime once again does not change and stays as ex. Now I rewrite the front part, and the integral part is going to be e to the power of x times sine of x, and minus the integral of ex sine of x. Now at this point, you might have already noticed something very special. We did integration by parts twice, and somehow we ended up back into the same integral as the one we were solving in the beginning. Since I set this integral ex sine of x as a variable I, that's exactly what I'm going to do now. Here I can simply write I is equal to negative cosine of x plus ex sine of x and minus I. This means I is the variable that I'm solving for right now, and I can move it from the right-hand side to the left-hand side. So that means 2i is equal to negative ex cosine x plus ex sine of x. And finally, I can divide both sides by 2, and that means I is going to be equal to this entire thing over 2. And this, ladies and gentlemen, would be our answer to the integral of ex sine of x. Now I will leave two integrals for you to try and solve using the cyclic integration method. If you want to check the work solution, please check the link in the description below for the PDF version of this lesson. There is also a link to a folder with all the PDF versions of the videos in this series for free. So that's it for now. Starting from the next video, as promised, we will begin applications of theoretical calculus. So I hope to see you there and have a nice day. Bye!